Okay, so hopefully this should work now. So work done by spring force. So in case of spring, it depends on how much you deform the spring, which means whether you compress it or you elongate it. What you do is called deformation. Whenever we deform a spring from its natural length, it is going to oppose it. So if I say this is the natural position, the position at which the spring is in the undeformed state or natural state, the spring force is zero. And once you try to deform by either going right or left, it really doesn't matter. The spring is going to oppose. So whichever direction you may choose, it will oppose the motion. If you try to elongate, it will oppose it. It will act towards the left. If you try to compress, it will act towards the right. And so the magnitude of spring force we write if it is displaced from its mean position by x value. So now this is something which you need to be careful about. So we are calculating the x from the mean. So x does not represent the position vector, it represents the displacement from the mean position. So many times you may get confused if I choose origin here and if I show it x. The spring force cannot be x. It is always the displacement from the mean position. And the magnitude of this force is always k times x, where x is the displacement from the mean position. So this is what we need to remember. Displacement, uh, not mean, with respect to natural length. So a spring force is this much. And direction is what? So it is the natural tendency of a spring force to go back to the natural length. So if you try to pull it right, the spring force will act left. But if you try to pull it left, if you try to compress it by pushing it left, the spring force will act this way. So no matter which direction you move, it is going to oppose the movement because the natural tendency is to go back to the natural length. So one thing is clear that if a spring is taken from the natural state to deformed state, the work is bound to be negative because it is opposing in the entire journey. But if you go from the deformed to the natural state, let's say if the spring is already deformed and it's trying to go towards this, now this is what spring wants, and therefore the work done by this force will be naturally positive. So that also reveals the fact that work done by spring can be positive or negative. So what we need to really understand is that whether it is taken from the natural to deform or vice versa. So if a spring goes from natural to deformed state, now deformed state can be compressive or elongation. It may be compression or it may be elongation. So both are called deformed state. The work done by spring is bound to be negative. And the other case is deformed to natural, the work done by spring is bound to be positive, and it is always opposing, so that's why it's positive. Now, the easy way to do the calculation is by graph. If you plot the graph between force versus deformation, so how to represent the opposite force? So x is the deformation basically, and I'm assuming that you're deforming from natural to deformed state. So spring force will increase gradually like this, and it will increase linearly. You can see the force formula is kx, so it's a y equals to mx formula, and because the direction is opposite, so it's a minus kx mathematically. So this is the graph of force, spring force, and let's call it x, and this will be now this value. If you deform by x, the value is this minus x, which is representing that it's acting opposite, and a positive force means acting along the x, and negative force means acting against the x. That's the meaning. And what we know that the area under the force displacement graph gives the work done. So we can find the area, and we take the signed area, like area with sign. Okay. So what is the work done by spring in this case? From
Half kx minus half kx.
to deform. So from natural to deformed state, the answer will be half into base into height, which is clearly saying the answer is minus half kx. You can also do by the integration, but this is the easier way to understand. So from natural to deformed state, the force is. But if you try to calculate the left side displacement, okay, so things will change. So if you go from left to right, then it is going to be positive. So deformed to natural, you can directly write work done by spring as plus half kx. Now the most important thing which you need to understand, the x measurement is always done from the natural length. It is not any random displacement. First thing you need to remember. Second problem with the spring forces, which 99% should make a mistake, that you cannot write the work done from any point to any point. The formula is only applicable if you go either from deformed to natural or natural to deformed. So what if I want to go from some one deformed to another deformed state? Like I don't want to go to natural. So those things we need to discuss now. So look at this situation, a scenario. So imagine this is the natural position for some spring. So this is the natural position. Okay. And the block is somewhere here, and it is being compressed. Let's call this is A. Okay. And then the block comes somewhere here. And just to confuse you, let me call this as B. And now the block is going from here to here. That's the direction of motion. So this is the natural, this is A, this is B, everything is given. If I call it A, if I call it B position, what is the work done by spring in going from A to B? Now this is the question to you. So what we can write? Okay, first of all, tell me, is it going from the deformed to natural or natural to deformed? Which state is it is trying to go?
Sir,
Deformed to
deformed to
natural.
natural.
So the work done by the spring is going to be positive or negative? Is the spring supporting the motion or opposing the motion? Tell me.
Supporting.
How
Suppose.
the spring force is acting? It is correct. So spring force is acting towards right because it is trying to go towards natural. So it's supporting. So work is bound to be positive. Now the question is, what's the answer?
Sir, half KB square. Sorry, K
That's
square.
that's absolutely incorrect. So if you answer this question, then you're done with the spring force. I mean, you really understand what is spring force. And this will also remove the drawback of thinking. Like you take it for granted. Now a half k square is something that everyone has taken for granted. So when you take something for granted, then you are committing some mistake for sure. So we cannot write the work done by spring for a intermediate position. That's what I explained to you. What I said is the only answer we can write is from the natural to deform or deform to natural, not from deform to deform. So I cannot write the answer from A to B. I cannot answer from A to O. Let's call it O as the natural. So I may write answer from A to O. I may write answer from B to O. That is in my capacity. I cannot write answer from A to B. Then I have to subtract to get the answer. So this displacement is how much? When you say this is how much?
Minus B.
So now work done by A to B is basically work done from A to O minus B to O because I need the intermediate value. This is the answer. I cannot write the answer A to B directly. I have to try to answer from A to O and from B to O, and then I can subtract to get the answer. Now A to O I can write as half K A square and plus because it's going towards it. And B to O we can write as half K and the displacement square. And so is this is the answer. Half K A square minus A minus B whole square. Now this could be the competition question. A plus B into A minus B. You can see that the work done by spring is not an easy thing to do. So you may be trapped with various notational symbols. So if you have really understood this, then solve this question. I will not disturb this page. Let me go to the next page.
Sir, I want to know.
Okay, anyone who wants to ask any doubt, if you have some doubt, why this is so, why I have written like this. Harshit, Athav,
No, sir.
Asna, you
No,
understood this?
Yes, sir.
Yes, sir.
No. So now let's do this question. I mean, okay, I can actually utilize this space also. So maybe. So origin is by default the natural length. So I need not to mention this again and again. So when I represent O, you can take it. Okay, it's natural. This is it. And now extend this. And now when a block is arriving somewhere here. The block goes from here to here. Maybe I can call it B. So now it goes from A to B, something like this. The question is, what is the work done by spring E in this case? Tell me. I think this is very straightforward. This is not a complex one as it was earlier.
1/2 k b square minus a square.
No. So you need to follow the definition. See, when I say something, it is very algorithmic. Like you cannot violate the same what I said. And if you follow the same which I said, there is no question in the world which cannot be solved. So every question do not demand different method of solving. It's what we need is a very algorithmic way of thinking. So once you have the a very clear concept of thinking, you can attack any problem at your will and solve. So try to follow what I said, and then try to come up with the answer. What are the logic which I share? So we're trying to go from A to B in the path, in the journey, we cross the natural position. And what I said is the work we can write only from any position to natural or vice versa. We cannot write answer from A to B directly. So how we are going to bifurcate this journey? First journey will be from
A to O,
correct, and then
O to
B
B.
to O to B.
O to B. That's your journey.
Sir, B
So
to
what
O.
number?
Sir, B to
No, O
O.
to B. You're not going B to O, you're going from O to B. You're going from A to B. That's your direction. So how are you coming from B to O? Are you going from O to B?
Sir,
You're going this way. So how you're moving?
sir, O to
O
B.
to O to B. So what is the problem? Like why are you getting confused so much?
Sir, no, I thought that it moved forward.
Don't think much. Think about the concept to get the right answer. So now the answer is obvious. Now tell me what is the answer for A to O? Is it deformed to natural, natural to deformed? Which is the
Deformed to
Deform to
natural.
natural.
Deform to natural.
so positive work or negative work? First of all,
Positive
Positive
one.
work.
Positive.
must be half A square. That's it. And O to B is what? Natural to deform or deformed to natural?
Natural to
Natural
deform.
to deform.
So what should I write here? Tell me.
Minus
Minus
1
K.
1
Minus
kb
half
square.
K.
And that's the answer. So I hope this is not a difficult thing. So once you realize that how to write things, it's pretty easy. Okay. I hope this is clear to all of you. Not clear? Clear?
Yes, sir.
Not clear?
Clear.
Okay. So once this is clear, we can solve actually a variety of problems. Now, before I jump to the numericals, some key points to be remembered. So although it's a later discussion, topic of discussion, but I need to explain here only that spring force is conservative force, which means the path doesn't matter. What matters is the deformation value. So spring force is conservative force. Therefore, work done by spring force does not depend on path, rather only on the amount of deformation. Now let's take some example to actually realize what I'm saying. So let's say there is a ceiling and there is a spring attached to the ceiling. And the natural length is L0. And when it is at a natural length, I attach a ball and I release it from rest. And now there is a ground actually. And this ground is H. And now this level, this height, so you release from H, and this is actually what I can say, I can say some length L. Okay, fine. Or let me just remove this part. So you release from rest. Now, so the idea is when you release, so while passing through its, when the bob will go to the bottommost position, it may be somewhere here. So it is not about L not. I mean, let me make it a little more space so that you can feel it. So when you release from rest, what will happen? How it will fall? While falling down, it will not take a circular path. It will take some random path like this. Because the length is also increasing while coming down. So when the bob will be exactly at the bottommost position, the spring may have been elongated by X. So the length of the spring while coming down something like this. You can see the spring is not having constant length, and now it might have elongated by some value X. So the new length is L naught plus X naught. This is the length. I mean, this is not required as now. I'll see. I have to make a question. So now you can see that the path is something very weird path. It's random. Now, if I talk about A to B journey, what do you think? Is it natural to deform or deform to natural?
Natural to deform.
Natural to deform. So work done by the spring will be positive or negative.
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 So work done by spring from A to B is going to be minus half k x square, where x is the deformation. See, no matter which path you choose, what I need is the final value of length of spring. Initial value of length of spring I will subtract to get the deformation. And if you are going from natural to deform, I'll use the minus formula. If you go from deform to natural, I will use the plus formula. It really doesn't matter which path it goes. So it is not only about the one dimension, even if you have to think in two dimensions. So for example, let me give you the third example, which is a very common example in various books. In fact, in SU Verma, there is one question. So we have a spring attached here. So this spring is fixed here actually. But the other end is not fixed, the other end is something like this. And there's a bangle attached here. So bangle can draw the bangle here. And the natural length is this. So this is the, when the spring is in this position, B. So B is a natural length position. So at B is spring at B spring is in its natural position. If I call this separation as let's call it H or maybe D, and if I call this angle as theta, so what is the work done by spring while going from A to B? Tell me, guys.
Minus half k d cos theta.
Okay, so is it going from
Square.
deform to natural or natural to deform?
Natural to deform.
Are you sure? A to B is natural to deform.
Sorry, I thought. Oh, sorry.
Deform.
How
So
are we
from deform
going?
to natural.
So work will be positive or negative?
Positive.
Positive. So I hope you can answer it. So what is the x value?
Or d cos
Is
theta.
is it x given to you?
So d minus d. Sorry, d cos theta minus d.
Are you sure? No, you're not sure. You're just trying to play with some random answer and expecting it to be true. Let's say again, I'm saying this is a very common habit. It's nothing wrong about it. But can be logical in thinking. Like I have been trying in my entire life that people should become rational, logical, and think in certain way. And but everyone fails to develop this habit actually, and that's why you feel difficult. Like I'm saying that the work done by spring is from deformed to natural plus half k x square, and x always represents the deformation, the deformation you had earlier, now you have. So what is this length? So if I call this length as L, I can say L cos theta equals to D. So basically L is D sec theta. So the x value in this case will be how much? It is L minus D. That was the deformation. It is L minus D. So it's a D of sec theta minus 1. Do you realize this? No. So the answer is half k d square, and because of lack of space, I mean, not have space actually. Okay, no problem. This will be half k d square sec theta minus 1 whole square. And these are the challenging problems. I mean, people call it challenging problem. It is, of course, because it is counterintuitive. This is not the way you think. That you are having very one-dimensional thinking procedure so far. So unless you will not create the two-dimensional thinking, uh, things will be difficult. So work done by spring does not depend on the path. So that's one thing. Second thing I said, from natural to deform negative, deform to natural positive. And third thing is we need to find, I mean, we need to know how to find the deformation, the change of length. That's very important. Okay, understood? Not understood? Okay, is this question clear, guys? Tell me, I mean, are you okay with this question?
Yes, sir.
Sir, L cos theta is equals to D half.
Okay, so right angle triangle. In a right angle triangle, this is D, this is theta, this is L.
Yes, sir. Okay.
Okay. So anybody else having this doubt in this second problem?
No, sir, no doubt.
So I hope now you realize how to write the work done by spring. And what is surprising for me that yesterday I had a discussion with Amit sir and he told that you guys are solving all questions. Almost you have finished the experiment. So are you doing it blindly without thinking? I mean, it just happens to be correct, or are you doing it by thinking proper, right manner? Okay, you don't know. Okay, that's also possible. You don't know what you're doing. Sometimes it happens. Okay. So on a philosophical side, let me tell you something. Solving numerical, getting the answer, and then realizing the process are three steps of solving. So when you solve for the first time, I expect that you might have only realized 10 to 20%. That why you solve like that, like the way you solve. Why you solve the way you solve is a big question. But when you solve a large number of questions, and if you're solving some of the challenging questions, try to also analyze why you solve the way you solve, and that will give you the idea that what exactly happens in the examination. Why even after solving all questions we fail in the examination? Why our performance do not reflect the same as we expect? And the answer lies here. You don't realize. So you do it by some formula, and the formula is in your favor. It's working. You get wrong, you just manipulate things. You change the sign and do something. You can get the right answer. You match the answer. You go ahead. In the due process, we fail to realize. So no amount of questions which you solve will guarantee a very good performance in the actual competition. So what matters is solve less number of questions. You may solve just 10 questions, but try to realize things. That's what I expect from every student. Okay. So now Walton by Spring is, we have seen it's a really sometimes challenging, sometimes it's easy. So we can go to the next question. So if you want to do more practice, I can give you more questions, but I hope this is sufficient. So after spring, the only force which is left, I think, is gravity, right? So let's do the work done by gravity. Now again, before I move next to the question, I need to mention certain thing about gravity, although it's not discussed, but gravity is conservative force. So spring force and gravity force in this particular chapter is bound to be conservative. These two are permanently conservative force, and therefore their work do not demand path. What it demands is the beginning and the end, and that's it. So gravity is conservative force, and it is independent of path. Now, for a small variation of height, let's say if you go from few hundred meters to few hundred meters, we assume g to be constant, unless you're not making some motion in the orbits and you change the orbit, you go from, let's say, one orbit to another orbit. In such case, the g is of course variable. Those are called astronomical distances. But as far as the small distances are concerned, compared to the Earth radius, which is 6,400 kilometers, so even up to 200, 300 kilometers, we take g as constant. Now, near the Earth, you can take up to maybe 400 kilometers. So you can take up to 400 kilometers. It's a near center. I mean, we ignore variation of g. G is the acceleration due to gravity, which we know. So we are going to treat the gravitational force for all such calculation as constant force. So the gravitational force is always mass multiplied by g, and it always acts downward. So g as a vector, the force vector is always acting downward. So you can also write as mg minus j cap if you want to write in the I cap j cap notation, assuming y is upward and minus y is downward. So the force of gravity we can write like this. So no matter which path you choose, you can choose any random path. Let's say if an object is thrown and it is moving this way, if you go from A to B, so during the all point of the journey, let me make it a nice curve because this is not too far. So gravity is always acting downward, right? So gravitational force is always acting downward. So no matter where you are, it is always acting downward. So work done by gravity only depends on the vertical displacement. So because I'm taking this as vertical, so what matters is if I know the initial height as let's call it h1, and if I call the other one as h2, these are called vertical position. So what matter is the vertical displacement. So what is the vertical displacement in this case? What is the delta y? So if I go take from A to B, what is delta y? Tell me what is delta y?
H1
Am I
minus
audible?
H2.
H1 minus H2.
Okay. And y is upward. Okay. So what is delta y? Now this is some basic problem with you in your thinking process. Like you have really not understood physics, like how to go about. Delta is a change which always reflects the
Final position minus
final
initial
position.
position.
It is h2 minus h1, which is of course negative. Okay. And so the work done by gravity turns out to be how much? So gravity is acting downward. So if you want to write in vector notation, you can say Fg dot ds integration and so on. And of course, here the angle is. So if you want to write in vector notation, you can see this is the dot product. This is the dot product. So how we can add delta y in notation? This is basically j cap. And if you actually do the mg, well, basically if you want to add the volume gravity, you can add as mg minus j dot minus h1 minus h2 j, and the j dot j becomes 1, so the answer is mg. Of course, your final answer is correct, but delta y means final mass initial position. And why these are very important things, like these are also very trivial, we ignore, but when you write examination or competition, everything matters. Now you may have two options given, plus and minus, so you may get confused why I'm getting plus sign or minus sign. So if the out of four option ABCD, if one option becomes just a replica of the one of the option which is having different sign, there you will get stuck. Now in this case, it's obvious you're going down, and you know the displacement in the downward direction, and force is also acting down, and therefore if you write only the product of force and displacement, it's always going to be positive. You can write directly mg into h1 minus h2. We know because this is the right answer, because the gravity is supporting the displacement, so it's positive. Fg is acting down, ds is down, so then you write the magnitude. Now if you want to write the magnitude, you can write as fg ds mod, right, the mod of fs. So if you write the f dot ds, this is constant, so you can simply write fg dot delta s, and this will become mod, and the angle between these two is 0, so cos 0. And now the magnitude is mg. The magnitude is h1 minus h2, the value is 1. So of course the answer is correct. So anyway, the work done by gravity does not depend on path. So let's do some calculation of work done by gravity in various numerical calculations. So these are going to be problems or numericals of future. Let's see how you can attempt. Very bright. So what you're looking at right now is the semi-circular cylinder. What is this? Semi-circular cylinder. And what we have is we have a small tiny block at the topmost point of the output. So ignore the size of the block, it's at the topmost point. And the radius of the cylinder is r. Now you give a gentle push. Let's say this is fixed. If you give a gentle push to the block will start sliding. Let's say surface is smooth, and after a while the block may be somewhere here. Let's say the angle is theta. What is the work done by gravity in the process from going from A to B? Very straightforward question. You should be able to answer. Try this question. What is the work done by gravity?
What, sir?
Pardon?
So can you repeat?
The question is on the board. You can read the question and make some sense to you. What is the work done by gravity? That's the question, right? So when you go from A to B, what is the work done by gravity? If I am audible to you guys, you can answer this question.
Yes.
So tell me, what is the work done by gravity? Okay, is gravity supporting the motion or opposing the motion? That's it.
So supporting the motion.
It must be positive answer. That's it. And what matters is the vertical displacement. So how much you have moved vertically down in the due process. What is your vertical displacement value was numerically only measured?
So it is r minus r minus r cos theta.
Correct. So what is the vertical gravity? Mg into r1 minus cos theta. So you are going from here to there. So actually you are going down only this much. This is your vertical displacement. Let's call it y. And in this triangle, the small triangle, you can see the right angle triangle. This is r. So this is definitely r cos theta. This is r cos theta. Do you realize this? And therefore the y value, the numerical value of y is r, which is full is r minus r cos theta. So you have come down only by this value. And so the work of gravity is mg r1 minus cos theta. Now these things are very common when you solve numerical, moving on a like cylindrical wedge, oscillation of pendulum. So let's say we have a pendulum. We have a bob attached to some thread. It makes some angle theta. This is L. And you, I mean, let's make it some other angle. Maybe I want to make it more complex. And you fall down till here at this point. Oh, this is nice. The bigger angle is alpha. This one is beta. This is the beginning. This is the end. The length of this thing is L. Gravity is uniform. What is the work done by gravity while going from A to B? Tell me. So what you need to calculate is how much you have gone down. That's your calculation. Now that is mathematics. I mean, it has nothing to do with the physics. Use the basic trigonometry and try to get the answer. So what is the work done by gravity? Please be quick. Don't waste time. No idea.
Findings.
Do it first. This is your question.
Sir, it's mg into L cos beta minus L cos alpha.
That's correct. So it is definitely, this is the displacement. This is a y. And you can easily find the y because y is L cos beta minus L cos alpha. So the answer is mgl cos beta minus cos. Anyway, the cos is a decreasing function, so a smaller angle will make sure it's a big value. So this is anyway positive answer. Don't worry. So how many of you got this answer or were very close
So
to
I
this
got the
answer?
same answer.
So same answer.
Same answer.
Very good.
Yes, sir.
So I hope this is not difficult. Okay. And the last question to wrap up this work done calculation. So now we are done with all types of work done.
Sir, can you send today's
Start.
PDF, sir, after the class?
Now this is what I do generally, but today I'll send you a bit late because I will start the next class and then we send you the afternoon.
Sir, okay. So, sir, because I missed some parts, sir, for writing.
Okay. So let's say if you have a pendulum which goes from this side to another side. This is alpha and this is beta now. So the question is, we go from A to B. So what is the work done by gravity?
MGL cos beta minus cos alpha.
It's the same answer. Correct. Okay, so now work done by gravity is something I hope you all have now mastered, and these will be applied in a basically vertical circular motion. So when I am going to solve the vertical circular motion at the end of this chapter. Okay. So in such scenario, we have to actually use all this work done definition. And also you're solving some question from SC or mass, you can do it there also. So today's lecture I will end here only because there was a conflict of two lecture, which is going to start, which is already started now, 4 o'clock. There's 2 minutes left.
So can we leave now?